In college algebra, we discussed the idea of the inverse function. And the concept, let me give you a little picture here. The concept is this. So we have a function. A function is a machine. You put something into the machine, it crunches it, you get something out the other side. Now, what's special about a function is that you put something in the machine and only one thing comes out the other side. A functional machine doesn't suddenly produce two things. You put something in the machine and two things come out. Now, that's the idea of a function. An inverse function is literally a machine that turns the conveyor belt on backwards. So our conveyor belt was going this way. Well, someone flipped a switch and now the machine is going back the other way. And so you go back into the machine the other way and you come out the way you started. So if you think about this, you put x in, you get y out. Well, now this inverse machine is going to go backwards. And if you remember this fancy language, the domain is what goes in the machine, the range is what comes out. Well, an inverse function flips everything. So all the domain and range are literally the other way around because the machine is going in the other direction. Now we're going to start doing that same concept here with sine, cosine, and tangent. We're going to turn this machine that we had backwards the other way. And so the point of this screen is that the domain of a trig function, in a trig function, you put in an angle, like down here I'm putting in sine of pi over 6. You put it into the machine, and what comes out the other side is the ratio. Remember, trig functions are really ratios of a triangle. So if we go in the inverse and we start making the machine go back the other way, then now the ratio is what has gone in, and what comes out is the measure. We're just going backwards. So look at some examples down here. So here's what we've got. So here's forward. I put in the angle, and the sine of pi over 6 gives me the ratio, 1 over half. Now, in an inverse machine, you put in the ratio, we put in 1 half, and we ask ourselves this question. Okay, well, what angle creates a sine ratio of 1 over 2? Well, it's pi over 6. And we'll go through each of these here. So if you put in the cosine of pi, you put in the angle, you get out a value of -1, a ratio. Well, if I said, hey, the inverse cosine says what angle has a cosine ratio of -1, it would be pi. And then lastly here, tangent of pi over 4, you put in the angle, you get 1. Well, you'd say, hey, what angle has a tangent of 1? Well, the inverse tangent sends us back and it says an angle of pi over 4. Okay, now there's something, the most challenging part of this is that we have to do something called restricting the domains. Let me show you what I mean by this. I'll go back to something that you probably, well, I may have talked about if you've watched my videos. So did you ever notice that when we do, oh, hold on, I should be doing it like this. Okay, did you ever notice when we looked at the square root function that it was only this curve here? This is the picture of a square root function. But why isn't it, shouldn't it be this? Do you see what I mean? Because if I put in 9 into a square root, it should be plus or minus 3 or the different values. So if I put in 9, I shouldn't only be getting 3, I could also be getting -3. Well, why is the graph of a square root function then just this one line? This one curve, I should say. It's because this isn't a function. If you draw a vertical line here, remember the vertical line test checks to see if something's a function. If you draw a vertical line here, this is not a function because it hits in two places. And so what we do is we do a trick. We say we limit the domain so that only certain values, we set a limit on it so that we can avoid this overlap. And the same thing is true here. What we're going to have to do in order to do inverse functions is we're going to have to set a limit. And I'll show you more about why here. But first of all, let's take about what those limits are. We are going to limit the sine function to be -pi over 2 to pi over 2. And this is an arbitrary point, arbitrary decision. And then cosine, we're going from 0 to pi. What we want is we just don't want it to overlap. Okay? So when we discuss this with just regular functions that weren't trig functions, what we said is in order to have an inverse, what we need is our function to be 1 to 1. Now I could give you a whole discussion on 1 to 1, but here's what you would check. You would do a horizontal line test. And you would check to make sure that horizontally you never hit in two places at the same time. Now again, this is an abbreviated version of this discussion, but here's the reason for this. If you create an inverse, it is going to reverse the domain and the range. It's going to flip them. But what happens to the picture is that it takes that shape and it flips it over this line right here. So let me give you another example. I hope this isn't too much. This is a lot in one shot, but this is a quadratic function. This is x squared. This is a function. Do you notice how if you draw vertical lines here, this is fine, no problem. But if you flipped it, if you did its inverse, it's going to flip it over this diagonal line. So if I flip this shape over the diagonal line, it's now going to go like this. Well, what's the problem? The problem is it no longer would pass the vertical line test and is no longer a function. Now, this is a long story to tell you this. We are going to have to restrict the domain of sine and cosine so that when we do the inverse and we flip them, they'll still be functions. Because if we didn't make these 1 to 1, if we didn't limit them, when we flipped them over this line, they would not be functions. So if I flip the cosine function, actually we're going to see it later on, if I flipped it, it would break. So if none of that made sense, here's what I'm trying to say in summary. In order to create an inverse of sine and cosine, we have to limit this. We have to cut it short over a domain for the sine and cosine that it doesn't repeat. So we need this to be a 1 to 1 function. So I've created this. So this is now 1 to 1. It would pass a horizontal line test, and all of that is necessary so that we could do the inverse. Now, the most challenging part of this section is you have to remember them. They are arbitrary choices, but they're the standard choices that will be used in the remainder of this textbook. So sine is going to be limited to negative pi over 2 to pi over 2. This is the domain that we want. And for cosine, it's going to be 0 to pi. Again, arbitrarily choice, but it's important. Now, one more thing. Notice here, well, let me show you on the tangent. Here's our limit to the tangent function. It's going to be from negative pi over 2 to pi over 2, but notice for sine, it was negative pi over 2 to pi over 2 with brackets. It's because we can get to negative pi over 2 and pi over 2. Do you remember this? We are allowed to get there. So those points can be included. But when you do the tangent function, we can't. We can never get there because negative pi over 2 and pi over 2 are asymptotes. We'll never reach there. So instead of brackets like we did on sine, we're going to do parentheses because we can never reach those locations. Okay, so when we flip these, here's what's going to happen. The ranges, what can come out, so if we're doing the inverse function, the domain and ranges will flip. So here this is just telling us we've flipped them. So what comes out of an inverse sine function has to be between negative pi over 2 and pi over 2. What comes out of an inverse cosine function must be between 0 and pi. And what comes out of an inverse tangent function must be an angle between negative pi over 2 and pi over 2, but we don't want to include the endpoints. We've got parentheses. Okay, now I know this is a lot of pretext stuff before we actually get to the problems. I don't usually have all this much talking, but take a look here. Here's what I'm saying. We have limited the sine function. It's this blue line. We have limited that. And the reason we've done that is when we flip it over the line y equals x, which always happens with inverses. You flip it over, we now have a function. It's still a function. So that's why we did all of this that we had to do. So we do the same. If we flip the cosine function is in blue, the inverse flips it over the line y equals x. Well, it's still a function. And then the same with tangent. Tangent between negative pi over 2 and pi over 2 looks like this in blue. We would flip it over the line to create the inverse. Okay. Yeah, this is all just saying what I've already said. Okay, so now we want to rewrite this with the inverse machine. We want to say, well, what happens here if we go backwards? So here's what we know. There's some angle that I put into a sine function that has a ratio of 0.96. Let's write it in terms of an inverse. How do we go backwards? Well, we'd go backwards, we would go like this. There must be some inverse function, sine inverse of sine of 0.96593 that creates an angle of 5 pi over 12. Do you see I've just gone backwards? Put in the measure, get out the ratio. Put in the ratio into the inverse machine, you get out the measure. So if we did this again here, we know that if we put in an angle of 0.5, we get a cosine ratio of 0.876. So what about an inverse cosine? Well, that means if you put in 0.8776, if you put in the ratio, you'll get out an angle of 0.5. Okay, now let's take a look at it and take this up a little bit of a notch here. So let's do it with some unit circle measures that we're more comfortable with. So here's what sine, the inverse of 1/2, the inverse sine of 1/2 would mean. I am looking for a value, what angle has a sine that's 1/2? Well, if you can look up your unit circle, or you can just think this through if you know it. But sine has a measure of 1/2 at pi over 6. So we want to inverse this. If we do the inverse of sine of 1/2, we get out a measure of pi over 6. Now, it's going to get a little trickier here in a second. Let's look at the second one. When does sine create have a measure of a ratio of radical 2 over 2, negative radical 2 over 2? When do we get this? What angle has a sine that creates this? Well, here's the problem. There are two of them. If you get out your unit circle, you're going to find 5 pi over 4 and 7 pi over 4. Both have a value of negative pi over 2. But here's the trick. This is what gets a little more difficult. We have to, out of an inverse sine, we have to get something that's in that range. Remember, we've limited this. So I have to get something out that's between negative pi over 2 and pi over 2, and neither of these are. So what are we going to do? Well, we have to use a coterminal angle. These two angles have this value of sine, but they're not in this range for the inverse. So what I'm going to do is I'm going to do coterminal angles. I'm going to try to force it into this region. These are too big. So what I'm going to do is I'm going to take away one spin around the circle. Do you see that this would create negative pi over 4? So an equivalent angle for 7 pi over 4 is negative pi over 4. Well, that is in my range. So I'm good. So what we're going to do is we said, hey, what angles have a sine of negative pi over 2? We found two of them. Here they are. But they're not in the range for the inverse sine. So we're going to spin around. We're going to use coterminal angles and spin around the circle till we find one that does negative pi over 4. Now, so we could have done the same thing. Let's look at 5 pi over 4, and let's take away 8 pi over 4. We'd get negative 3 pi over 4. This one still is not acceptable. That is still not within our range, so we don't want to use that one. It must be this. Okay, this is a little tricky. Let's take a look at some more here. Okay, so we want to say what angle gets a cosine ratio of negative radical 3 over 2. Let's go in reverse. Well, if we look this up on our unit circle, 5 pi over 6 is an angle that gets negative radical 3 over 2. Now look, 5 pi over 6, that is in the acceptable range for the inverse function. So we're done. That one worked. That was perfectly fine. So we don't have to spin around the circle. We're just good. Okay, now one more. Let's try to send tangent backwards. And we want to say, when does tangent have a value of 1? Well, it's at pi over 4. Okay, well, is pi over 4 in the acceptable range for an inverse function? Yeah, it really is, so we're good. So that one was fine. We didn't have to do any tricks. Okay, let's practice this. Now, you can pause the video if you think you got it, but let's talk through this ourselves here. I need to know what angles create a sine ratio of -1. What angles do that? Well, -1, if you look on your unit circle, is going to be 3 pi over 2. Now, here's the problem. Inverse sine has to be limited between here and here. And this one's not in there. So what do we do? Well, we've gone too far. This is too big. So let's try spinning ourselves around the circle. Sorry. One time. See, I've got a common denominator. This is just 2 pi. This is one spin around the circle. So I've gone too far, so I'm trying to go back. And I'd get -pi over 2. Now you say, is this acceptable? Yes. And notice here, it wouldn't be acceptable for tangent, but it is for sine because sine includes -pi over 2. So let me talk you through this. There's a bunch more, but let me talk you through this. So what angle has a sine of -1? Well, that's 3 pi over 2, but it's not in the acceptable limits for an inverse sine. I'd gone too far, so I just used a coterminal angle. I spun back around the circle one time, and I got -pi over 2, which is now okay. That's all right. So the answer here is the sine of inverse of 1 is -pi over 2. Now, when is tangent equal to -1? Well, the angle that has tangent that's equal to -1 is, let's see, 3 pi over 4. So you can check this on a unit circle. Remember that it's sine over cosine. So in the second quadrant, at 3 pi over 4, I get a value, a tangent of -1. But this isn't in the acceptable region. It has to be between -pi over 2 and pi over 2. You with me here? Has to be within that region. And we've gone too far. So let's subtract. So I don't have a lot of space here, but let's go down here. 3 pi over 4, we're going to go 8 pi over 4. Do you see that's still 2 pi. I'm just taking off a trip around the circle. I've got -5 pi over 4. And I'm still too far. So, yeah, I'm still too far. So I need to spin around one more time. I think that's what I've got to do. No. Hold on, I've got something wrong. Let me pause this real quick. Sorry, I see what I did. So I tried to spin all the way around with a tangent function, but a tangent's period is not 2 pi, it's pi. So let me start this one over. Okay, so we're looking for an angle that has a tangent of -1. Well, that angle is 3 pi over 4. Now, that is not in our acceptable region. So our acceptable region is -pi over 2 to pi over 2. Okay, so I've gone too far. So what I need to do is not go all the way around the circle, because the period of a tangent function is pi, not 2 pi. So I'm going to take away 4 pi over 4. And so -pi over 4 has the same value. And that is acceptable. So one more time, sorry if this is confusing, especially with me screwing it up. But so where does tangent have a value of -1? 3 pi over 4. That's where. Okay. It's not in the acceptable parameters for an inverse tangent. So I'm going to subtract But because it's tangent, because it has a period of pi, I don't want to go all the way around the circle. I'm going to subtract away 1 pi, which is what I've done here. And I get negative pi over 4. And that's in there. Do you see that would fit in there? So the inverse tangent of negative 1 is negative pi over 4. I had to modify this so that I could find the same value, the same truth, in the acceptable range. Okay, let's try a couple more. How about cosine? What value of cosine, what angle has a value of negative 1? Well, that's pi. Now this one's okay. So what are the acceptable values for cosine? We said we were going to go from 0 to pi. So we're okay. So you're going to have to memorize those acceptable domains and ranges for an inverse. You got to memorize those. So this one was fine. So the inverse cosine of negative 1 is pi. Okay, now what is an angle that has a cosine of 1/2? Well, that is a 60 degree. So yeah, that's a 60, which is pi over 3. Now that one too, that's acceptable already. I would check to see, is this in the acceptable range? And it is. So these last two don't require any modification because their initial answer was in the acceptable range. Okay, lastly, we're just going to see how do you do this on a calculator. So if you have a scientific calculator, you have the fancy, any kind of Texas Instruments calculator, you have a button for inverse sine, inverse cosine, inverse tan. You just have to hit the Alt key. So I've got a second button above sine, a second button above cosine. That's all you have to do. The only thing that you've got to be careful here is don't forget you've got to be in the right mode. You've got to be in either radians or degrees, depending on what kind of angle you're working with. It mentions here calculus. As you move forward, more advanced stuff, you'd always just be in radians. Now, one other measure or point here, that if you the inverse sine, cosine, and inverse tangent are going to use those same limits that we've set here, the same restrictions. So if you get an error, it means that you're trying to put in a value that is outside of those limits. So one last time, remember, inverse sine has got to have a range between negative pi over 2 and pi over 2. Inverse cosine has to have a range between 0 and pi. And inverse tangent is a parenthesis, between negative pi over 2 and pi over 2. So if you put in a value and try to find out, okay, calculator, tell me what angle has these values, they have to be in here. If it's outside of these ranges, it's going to break. It's going to say error. So real quickly here, I'm assuming, I don't know what mode am I on here. Okay, I'm in radians, which is I'm assuming what this question is referring to. So I'm doing the inverse cosine of negative 0.4, and I get a value of 1.98. Okay, so try that, just make sure that you've got it. Okay, now that was a lot, but it's really important as we move forward that you've got those restrictions, and hopefully you understood where all of that came from my discussion.